Hi, welcome to the video of multiplication modulo. In this video, we will discuss about multiplication modulo n and its properties. At the end of this video, you will be able to define the concept of multiplication modulo n and list the properties of multiplication modulo n. So now, let's define what do you mean by multiplication modulo. It says that suppose n is a positive integer and a and b are any two integers. It can be positive, it can be negative. Then multiplication modulo is nothing but it is the least non-negative remainder when ab is divided by n. So just like the addition, in case of addition modulo, it was a plus b divided by n. Here in case of multiplication modulo, it is multiplication of ab, means a and b, and divided by n. The least non-negative integer is called the multiplication modulo n of a and b, and it is written as a cross b, and n should be at the base of the cross. So looking at more appropriate definition, it says that if r is a remainder, when ab is divisible by the number n, then we define a multiplication modulo b is equals to r, but where the values of r exist, r lies in between 0 and n. But r can be equals to 0, but it never be equals to the number n. So let's understand the concept of multiplication modulo with the help of some examples. Let's consider the first example. Here a is 7, b is 3, and the number n is 5. So how to calculate the multiplication modulo of this number? What we will do is, simply we will multiply 7 and 3, it comes out to be 21. Now you will divide this 21 with the number 5. So the remainder, the least non-negative remainder is 1. So this is how to calculate. In the other example, a is 9, b is 5, and the number n is 7. So how to calculate this multiplication modulo with respect to this number 7? Multiply 9 and 5, it comes out to be 45. Divide 45 by 7, the least non-negative integer is 3. In this example, a is your number 12, b is your number 7, and n is your number 8. Follow the same procedure, multiply 12 and 7, the number is 84, divided it by 8, the least non-negative integer is 4. Similarly with this example and this one. Let's study some properties of the multiplication modulo. Just like the addition modulo, they have the properties commutative and associativity. Similarly, the multiplication modulo also have the same properties, commutative and associative. So what does commutative property says that a multiplication modulo b is equal to b multiplication modulo a. Why? Because the multiplication of ab or ba have the same remainder when you will divide it by n. So this means that commutative property holds for multiplication modulo n also. Similar is the case with the associativity. It says that if a, b, c are three elements from your group or from your set, and n is any number non-negative, n is any integer, then if you are going to multiply first a and keep it outside and take its multiplication modulo with the multiplication modulo of b and c, it is equivalent to saying first take the multiplication modulo of a and b and then take the multiplication modulo with c. Why? Because multiplication of integers, they are always associative. So if you will multiply 1 into 2, the result is 2, 2 into 3, it is 6, or first you will multiply 2 into 3, the result is 6, and then multiply it with 1, it is always going to be the same. So same number, if you will divide by the same number n, its remainder always going to be the same. So this shows that multiplication modulo holds good for associativity law also. Let's understand it with one example. Suppose you have a set Z5, it consists of numbers 1, 2, 3, 4. Now we want to show that this Z5 is a group with respect to multiplication modulo 5. So to show that it is a group, we need to show that it satisfies the 4 axioms of the group. So let's calculate the table to show that it is a group. So just like the addition modulo, we will make a table for the multiplication modulo, and we will apply the rules for the multiplication modulo in this table. So looking at the first row and the first column, first take the first row of the table. We are calculating the first row of the table. 1 into 1 is 1. Keep it as it is because the number is less than 5. no need to divide it by 5. 1 into 2 is 2, no need to divide it by 5 because the number is less than 5. 1 into 3 is 3, keep it as it is. 1 into 4 is 4, keep it as it is. Moving to the next row. 2 into 1 is 2, less than 5, no need to divide it by 5, keep it as it is. 2 into 2 is 4, less than 5, keep it as it is. The next one, focus on the next one. 2 into 3, it is the number 6. So now we will divide 6 by 5. So remainder is 1. So this is the least non-negative remainder. Similarly, 2 into 4 is 8. You need to divide it by 5. The least non-negative integer is 3. Moving to the next row, 3 into 1, 3, keep it as it is. 3 into 2, 6, you will divide it by 5, the remainder is 1. 3 into 3 is 9, divided by 5, least non-negative remainder is 4. 3 into 4 is 12, divided by 5, the least non-negative integer is going to be 2. Moving to the last row, 4 into 1, keep it as it is 4. 4 into 2, 8, divided by 5, the remainder is 3. 4 into 3 is 12, divided by 5, remainder is 2. 4 into 4 is 16, divided by 5, least non-negative integer is 1. So this is how we are going to calculate the table. Now looking at this table, we have to show that this Z phi, it satisfies all the 4 properties of the group. So now let's check all the axioms of group. First is the closure property, which is very much clear from the table that if you are going to take any two elements of the Z5, their multiplication modulo with respect to 5 is again going to be an element of Z5. Means that it is always going to be a number from 1 to 5. Similarly, the associativity law, if you will look at the table, you can easily show that A multiplication modulo 5 into B multiplication modulo C is always equivalent to first taking the multiplication modulo 5 with respect to A and B and then taking the multiplication modulo with respect to C. The result is always going to be same. The identity element of Z5, if you look at the table, you will find out that the number 1 is the identity element. How it is going to be identity element? Because if you are going to multiply 1 with any of the elements from the Z5 and divide it by 5, the result comes out to be the number itself. So this shows that 1 is the identity element of Z5. Next, our job is to find the inverse. So if you will look, inverse means that if you are taking one number, another number, their multiplication should be identity number. So what you have to do is look at the table. For every number where you will find the identity which is 1, move to the top head of the table, whatever be the number, that is going to be the inverse of that number. So this is what it is written, that the inverse of 1, 2, 3, 4, if you will look at the table, its inverses are respectively 1, 3, 2 and 4. So this shows that Z5 contains inverse of every of its elements. So in this way we have proved that Z5 is a multiplicative group. In this video, you learned that multiplication modulo n of two integers a and b is defined as least non-negative remainder when a and b are divisible. A multiplied by b is divisible by the number n. And we came across with the properties applicable to multiplication modulo, which are commutative and associative. Multiplication modulo is the basis of number theory. It has found applications in other branches also, like cryptography, integer factorization, primality testing and so many.